This video is sponsored by codingskill.net. Please visit our sponsor. Let's work through linear search problem. Given a and x, find an index I for which a of I equals x. A is an array and x is an element. We want to find if this element is in the array. Pause the video now and solve this problem using recursion. The time complexity is O of n. What is the size of the problem? The size is n, length of the list. What is the base case? Empty list is the base case. We return -1 in this case. In the decomposition step, we reduce the size of the problem by discarding the last element. Base case checks if x is located at the last position. In code, this will look like this. We check the last element is equal to the element that we are searching in the list. If so, we return the index of that particular location. Otherwise, we make a recursive call to solve subproblem of size 1 less than the previous size. And we return the result of the subproblem. You may recognize this as tail recursive algorithm. Let's look at a tail recursive algorithm. The method takes two parameters, the array A and the element X that we want to search in that array. We first find the length of the list, and if the length is 0, we return -1 to indicate we did not find the element in the list. Otherwise, if the element is the last element in the given list, we return the index of that particular location. Here we reduce size by 1. Since n is the length of the list, n minus 1 chops off the last element in the list. In the problem decomposition step, we have two options. Let's first see the option number 1, where we discard the last element. If we have these elements in the list, this entire thing is a problem, and this subset that excludes the last element is a subproblem. The indices of these elements are shown here, and index is the same for problem and subproblem. Option number 2 is we can discard first element of the list. So if we have these elements, and if we discard the first element, these are the indices of the elements, and this smaller list now has these as the previous indices, and the new updated indices are these values. So we need an additional parameter to handle this scenario. So the method now has 3 parameters. A and X is the same as before, but we also have N, which is the index. If the list is empty, we return -n subtracted by 1. Otherwise, if the element is in the beginning of the list, we will return 0, because 0 is the index of the first element in the list. Otherwise, we'll make a linear search call, and we will discard the first element from the list and pass in X as well as N. N will be 0 in that particular recursive call. So if A is empty, we will be returning -1 as the result, which means we did not find the element. If element is in the beginning of the list, we found the index of the element, and this is the trivial case. So you can see we add a unit to the result of each recursive call. So we will have a linear search wrapper that takes two arguments, and we will call the linear search method, and we will seed this n to the length of the array. Here is the alternative solution. We explicitly specify the index of the element that will be compared to x each time the method invokes itself. We need a new parameter that is incremented within each function call and leads to a tail recursive function. So we have a, x, and index. And if the list is empty, we return -1. If the element is found in the first position of the list, we return the index value. The result is stored in this index parameter. Otherwise, we make a recursive call and we eliminate the first element in the list, and we also increment the index by 1. And we have a linear search wrapper that takes two arguments, and it seeds the index value to 0 when it calls the linear search. So here the accumulator index is set to 0. Sign up for your free coding interview coaching call. Sign up for your free coaching call by going to codinginterview.coach.